Find the point or points where the tangent line for 2x squared plus 8x plus 4xy plus y squared equals 6 is A, horizontal, and B, vertical. A horizontal line has a slope of 0. A vertical line has a slope of positive or negative infinity. And we want the slope of the tangent line to be these things. The slope of the tangent line is the derivative, so we need to find the derivative of the equation given to us. 2x squared plus 8x plus 4xy plus y squared equals to 6. This is an implicit equation, so we will have to take the derivative implicitly, since we do not have y solved in terms of x. To take the derivative implicitly, we take the derivative of both sides with respect to x. The first term on the left is a power rule. Bring down the power, multiply it with the 2, subtract 1 from the power. Second term is a constant times x. The derivative will be the constant. The derivative of the third term is a product rule of 4x times y. The derivative of the first is a 4 times the second left alone, y, plus the first left alone, 4x, times the derivative of the second. The derivative of y is 1 times y prime. Every time we take the derivative of a y term, we multiply the result by y prime to complete the chain rule. The fourth term, y squared, is a power rule. Bring the power down, subtract 1 from it, and then multiply by the derivative of the inside, which gives us another y prime. On the right side, we have the derivative of 6, which is 0. We want to isolate the y prime terms. We have 2 of them, here and here. They're both positive already, so I'm going to keep them on the left side. That means we will take these other 3 terms and move them to the right side. So we have 4x y prime plus 2y y prime equals 2. Moving the 4x over, negative 4x. I'll now move the 4y over, negative 4y, and then the 8 over just so the constant comes last, negative 8. We can factor a y prime out, which will leave us with a 4x plus 2y equals to the negative 4x minus 4y minus 8. And to solve for y prime, we can divide both sides by what's inside of the parentheses on the left side. Giving us negative 4x minus 4y minus 8 over 4x plus 2y. Each of these coefficients has a common factor of a 2 in the numerator and denominator, so we can factor the 2 out, in which case it'll be able to cancel. That will leave us with a negative 2x, a minus 2y, and a minus 4 in the numerator, and a, factoring it out, 2x and plus y in the denominator. The 2's can now cancel with each other. And so our derivative y prime, which is the slope of the tangent line, is equal to negative 2x minus 2y minus 4 over 2x plus y. For part A, we want to find where the tangent line will be horizontal. This happens when the slope, which is the derivative, is equal to 0. For the derivative to equal 0, we need the numerator down here to equal to 0. So we have negative 2x minus 2y minus 4 equals to 0. We can add a 2x and a 4 to each side, which will give us negative 2y equals 2x plus 4. And now we can divide both sides by negative 2. So y will be 2 divided by negative 2 is a negative 1x, and then 4 divided by negative 2 is a negative 2. There's the relation between y and x for the horizontal tangent to happen. To find the points, we need to take this relation and plug it into the original equation here, which is 2x squared plus 8x plus 4xy plus y squared equals to 6. Everywhere we see a y, we will replace it with a negative x minus 2 from our relation. So that means 4x times y will be negative x minus 2, and then y squared will be negative x minus 2 squared. And all of this equals to 6. So we have 2x squared plus 8x. Here we will distribute the 4x into those two, giving us negative 4x squared and a minus 8x. And then here we will need to FOIL that out. We have a negative x minus 2 multiplying itself. It's best to write it side by side to FOIL it. All this is equal to 6. We can combine like terms together. 2x squared and a negative 4x squared make a negative 2x squared. The positive 8x and the negative 8x can cancel each other out. And now we can FOIL the negative x minus 2 times itself. Negative x times negative x is positive x squared. Negative x times negative 2 is plus 2x. Negative 2 times negative x is plus 2x. And then negative 2 times negative 2 is positive 4. And all of this equals to 6. If we combine like terms together, we have a negative 2x squared plus an x squared. That'll be a negative x squared. I have a plus 2x and another plus 2x, which is plus 4x. And then I have the plus 4. I'm going to subtract the 6 over, which will give us a minus 2. So we have it equated to 0 since we have a trinomial quadratic here. Let's now multiply both sides by a negative 1 just to make the x squared term positive. And that'll change the sign of each of the terms. We can try to trinomial factor this. We need two numbers that multiply to be a positive 2 and add to be a negative 4. But positive 2 can only be a 2 and a 1. And they can both be negative or both positive, but there's no way those can combine to be a negative 4. So this is not factorable, therefore we have to use the quadratic. The quadratic equation says x will be the negative of whatever b is, so that'll give us a positive 4, plus or minus the square root of the b squared minus 4 times a, which is a 1, times a c, which is a 2, all over 2 times a, 2 times 1. So we have 4 plus or minus the square root of negative 4 squared is 16, and then a minus 4 times a 1 times a 2 is a minus 8, all over 2. So we have a 4 plus or minus the square root of 16 minus 8 is an 8 over 2. And it turns out 8 is 4 times 2, so there is a perfect square in that root, but the 8 itself is not a perfect square, just the 4. The 4 can come out of the root as a 2, but there will be a 2 left over inside the root, because 8 is 4 times 2. We can put each of those over 2 separately, so we will have a 4 over 2 and a plus or minus 2 root 2 over 2. 4 over 2 is a 2, and then plus or minus, the 2's can cancel in the second term, and that'll be just root 2. Now these are two different results here, so we have one of the x's is 2 plus root 2, and one of the x's is 2 minus root 2. Now the corresponding y back up here is the negative of x minus 2 for each of these. So y for this first one will be the negative of the x, which is 2 plus root 2, and then minus 2. If we distribute the negative sign, we'll have negative 2 minus root 2 minus 2 more. We can combine the minus 2's together, and that'll give us negative 4 minus root 2. So we have an x-coordinate of 2 plus root 2 and a y-coordinate of negative 4 minus root 2. For the x-coordinate of 2 minus root 2, the y again is negative x minus 2. We'll plug the x in as 2 minus root 2, and then all of that minus 2. Distributing the negative sign, we'll have negative 2 plus root 2, and then minus 2. Combine the negative 2's together, we will have negative 4 plus root 2. So we will have an x-coordinate of 2 minus root 2 and a y-coordinate of negative 4 plus root 2. There's the 2 points where the tangent line is horizontal. For vertical, we want the slope of the tangent line, which is the derivative, to be positive or negative infinity. This occurs down here for the expression for the derivative when the denominator equals to 0. So we will have 2x plus y equals to 0. That means y will equal to negative 2x if we subtract the 2x to the other side. And that result can be put into the original equation to solve for the points. So 2x squared plus 8x plus 4xy plus y squared equals 6 will become 2x squared plus 8x plus 4x times a negative 2x plus a negative 2x quantity squared equals to 6. So we have 2x squared plus an 8x. A 4x times a negative 2x is a negative 8x squared. And then a negative 2 squared is a positive 4, and an x squared equals to 6. We can combine like terms together. We have a 2x squared, a negative 8x squared, and a 4x squared. 2 minus 8 is negative 6 plus 4 is a negative 2. So we'll have a negative 2x squared. We have a positive 8x, and then we can bring the 6 over by subtraction so that it's equated to 0, so we can attempt to factor this. Now we can factor a negative 2 common factor out of there, leaving us with x squared minus 4x plus 3 equals to 0. And that can factor into two numbers that multiply to be a positive 3 and add to be a negative 4, and that'll be negative 3 and negative 1. So it looks like our x will be a 3 or a 1. Now we're under the condition that y is negative 2x for this situation here. So if we have x is a 3, the y will be negative 2 times 3, which is a negative 6. So we have the point of 3 comma negative 6. And if our x-coordinate is a 1, we have y equals negative 2 times 1, which is a negative 2. So you have an x-coordinate of 1 and a y-coordinate of negative 2. And there's the 2 points where the tangent line will be vertical.